Unit 6th. EM waves. Ampere's circuital law. Already done. This is a closed path. This is conductor in this closed path. It is carrying current I. Then B dot dl mu naught I. Integration. Closed path. Line. Integral of magnetic field. Line integral of magnetic field of this one of closed path is mu naught times I. Conduction. करंट. वायर है ये, कंडक्टर है, कंडक्टर में करंट, कंडक्शन करंट एंड क्लोज्ड इन क्लोज्ड पाथ. ये एडिशन किया हमने यहाँ. वायर में करंट है, ये कंडक्टर में करंट है, तो दिस करंट इज व्हाट? कंडक्शन करंट. This was your Ampere circuital law. Maxwell displacement current. This is a capacitor in circuit which is charged. This is plate A, this is B. Charge start flowing. When a capacitor is in circuit, here current in wire is conduction current, but here there is no wire. So what should be this current? And that current was Maxwell displacement current. How? When a capacitor is in circuit, it is being charged. This plate, positive charge is coming. This plate is positive. By induction, this plate is negative. More charge is coming, positive, negative. More charge is coming, positive, negative. When capacitor is in circuit, it is being charged and plate A, positive charge, start increasing, and in B plate negative charge start increasing. A plus charge or plus more plus charge, more plus, more plus. So if this is plus, this is minus, this is direction of electric field. So electric field start increasing. As this plate is negative, it will repel electron like this. Plate B will repel electrons. Plate A, why it will repel? Negatively charged. Plate A will attract electrons. So electron moves from plate B to A. Hence, current between plates is from A to B, called Maxwell displacement. Correct. Electrons are moving from this to this. So this is current. ID displacement current. So this current is conduction current. This current is what? Displacement current. So what is definition? Current produced between plates of capacitor by varying electric field. Vary हो रहा है electric field, and because of displacement of electrons, इलेक्ट्रॉन डिस्प्लेस हो रहे हैं एक प्लेट से दूसरी, कॉल्ड मैक्सवेल डिस्प्लेसमेंट करंट. So this is what experiment performed by Maxwell, so it is Maxwell displacement current, and this is what definition of Maxwell displacement current. It is denoted by ID. Expression for Maxwell displacement kind. We know displacement current, that is ID, dq by dt. Electric flux, Q by epsilon naught. Electric flux E dot ds. Gauss theorem. From Gauss theorem, it is d dt Q epsilon naught phi E. Epsilon naught out d phi E by dt. This is expression for displacement current. Importance: it has modified Ampere's circuital law from B dot dl mu naught I to B dot dl mu naught I plus ID. Outside this is zero. ये current, ये factor, this thing is not increasing. I plus I not increasing. Outside this is zero. Inside conduction current is zero. Inside capacitor. Outside capacitor this is zero. This is what mu naught I plus ID epsilon naught phi E d phi E by dt, or it is mu naught I mu naught epsilon naught d phi E by dt. This is Maxwell Ampere circuital law. It gives continuity of current throughout circuit in which capacitor is used. Because inside capacitor, before this current, there was discontinuity. It was thought there is no current inside plates of capacitor. So after this, continuity throughout circuit. Outside, because of conduction current, continuity. Inside, because of displacement current. This is about what? Maxwell displacement current. Relation between Maxwell displacement current and capacitance of capacitor. This one. We know Maxwell displacement current ID epsilon naught d phi e by dt. Phi e it was EA E dot ds integration. So this is phi epsilon naught d dt E A outside dE by dt. To bring C capacitance epsilon naught A by D, there should be D here. So B E dot dl. In case of capacitor, E dot dl is ED. Epsilon naught A d dt E V by D. So D is out. dV by dt, or it is what? C dV dt. So this is relation between displacement current and capacitance of capacitor. So displacement current is equal to conduction current. Again, ID dq by dt phi same as we already done, d dt epsilon naught phi e, epsilon naught out d phi e by dt. This is first, but phi was E, Gauss theorem. Epsilon naught d dt E, epsilon naught A out d by dt E. Now this is displacement. Here there should be current, so this should be cancelled. How it can be possible? We also know E sigma by epsilon naught. Then sigma naught will be cancelled. Epsilon naught A d dt sigma by epsilon naught. A is there, d dt epsilon naught out will be cancelled with this sigma. Now E should be cancelled, but sigma, it is Q by A. This was a small q, it is now capital Q. Another A d dt Q by A. A goes with A, dq by dt, or it is what? I. Hence what? Proved. Maxwell Equations. A dot ds Q by epsilon. First Maxwell equation. Second, E dot dl, line integral of electric field, is d phi by dt, rate change in magnetic flux. V means potential difference voltage. Third, E B dot ds Q by epsilon naught, total charge enclosed, total pole strength enclosed is 0. This is Gauss theorem in magnetism. B dot dl mu naught I, mu naught epsilon naught t phi e by dt. These are what? Maxwell equations. Maxwell equations for study electric field. First, left side as it is. In right side, study electric field, no. So it is q by epsilon naught, same. Left side. Right side, magnetic flux is there. Study electric field, so no electric field as it is. Third, B dot ds is what? No electric field. Fourth, B dot ds, B dot dl, mu naught I. This is electric field. It is constant. Differentiation of constant is 0. Electric field, electric flux, so electric field A. Electric field is constant, differentiation 0, so this is 0. So our Ampere circuit law was when there is no varying electric field. These are what? Maxwell equation for study electric field. Maxwell equations for study magnetic field. First, left hand side remains same, E dot ds. Magnetic field, no, it is q by epsilon naught as it is. Second, E dot dl, left side remains same, magnetic field study. So flux study means constant, differentiation of constant is what? 0. Third, B dot ds, it is 0. Fourth, B dot dl, mu naught I. Magnetic field constant, not electric field, so it remains same. These are what? Maxwell equations. EM waves are transverse waves. Suppose in this direction E varies, in this direction B varies, then marker will be direction of EM wave. E varies as shown on board, B varies or as shown, and marker direction. This means these are transverse waves. How EM waves are produced? Brief. Oscillating charge. If charge oscillate like this, E, if charge is here, this is E. If charge moves like this, E decreases, back, E increases, again decreases. If charge oscillate, E decreases. What? Make current loop. So B also varies. E varies, B varies, so EM waves, oscillating charge will produce between plates of capacitors. Because as E varies, B will vary, so EM waves will be there. Charge moving in circle with constant speed. E will vary. How it will vary, we will take it later on. Constant speed, accelerating charge. Why? Velocity changes in circular motion. Velocity changes, speed constant, magnitude of velocity remains same. Because of direction, velocity changes. So, oscillating charge will produce EM waves between plates of capacitor. EM waves will be there when charge oscillates. Moving charge in circular path. Properties of electromagnetic waves. E. Electromagnetic waves. EM waves, electromagnetic waves. First property. They do not require medium. for their propagation or their motion. These are transverse waves. Here E varies, B varies, both perpendicular to each other and both perpendicular to direction of EM waves. This is plotting. Suppose this is x-axis, this is y-axis, this is z-axis. The direction of EM wave, this is direction x-axis. Then this is varying electric field. Electric field 0 increases, maximum decreases, again 0, maximum, varying electric field. Direction x-axis, it varies y-axis, then magnetic field. Will vary so this is B, varying magnetic field. This is what plot of EM wave. Velocity of EM wave, that is C, mu naught epsilon naught under the root, that is 310 p 8 meter per second in vacuum. Momentum of EM waves, that is small p, it is mc, it is mc square by c, it is u by c, where u energy of EM waves. Intensity of EM wave is energy per unit area per second, that is I. It is energy per unit area per second. So it is U A T. This is intensity of EM wave. Pressure exerted by EM waves that is P. Force upon area F by A. F, rate change in momentum so it is rate change in momentum upon area into time. These are properties of EM waves you have to remember. No medium, transverse, this is velocity of EM waves in vacuum, this is momentum, this is intensity, this is pressure.